Okay, and now in order to find and calculate your magnetic declination, if you are not given the declination angle, but given a previous angle in terms of when the map was the last time the angle was calculated, okay, then what we look at is we take the information we've been given and we can then work out what the angle is currently by either plussing or minusing a change. So every year, magnetic north is moving. And it is constantly moving, and they work out the average. And so what they do is they will say, on average, for the whole year, over a period of time, maybe 5 years, that's how they find the average, the magnetic north has moved 5 minutes, either west or east. If it has moved west, all right, to the left, then the pizza slice is obviously going to get bigger, okay? And that's when we plus. But if the angle is moving to the east, then it's going towards the right, closer towards true north, then my pizza slice is going to get smaller, and so that's when it is minus. Okay, so just bear in mind the plus and the minus, and I will show you where that comes in the sum. Now, the important information in the sum that we need to focus on, and this information is printed on the actual map, is they tell you what the average declination angle is for a particular year. So mean magnetic declination is the average size of the pizza slice, if I have to translate it into an easier way of understanding it. The average size of a pizza slice in 2001 for this map, okay, that's what's important, was 20 degrees and 28 minutes in terms of a size of an angle. All right. Then mean annual change is the average change in terms of whether the pizza slice got bigger or smaller. And so on average, this pizza slice got bigger by 8 minutes every year. And how do I know it got bigger? Because it moved westwards. Okay, it plussed, it got bigger. And that is the key information we want to focus on. So we now can calculate, it says, the question says calculate the magnetic bearing from the clinic to the spot height, and there's a map example that we're going to use. But before we even work out magnetic bearing, that's a separate sum. What we want to focus on is how to find the current magnetic declination angle. So if I'm looking for the magnetic declination angle for 2021, I'm going to say it's now 2021, and the angle was measured in 2001. So how much time has actually passed since 2001? Well, we can see that it's 20 years. Okay. Now that I've got the number of years that have passed, I'm going to times that by how much it had actually increased by every year or decreased by, whatever the change is. So 20 years, and I keep using the reference of the unit so that I know what I'm doing. 20 years times the annual change of 8 minutes, and we know that 20 times 8 then gives us 160 minutes. So now I can see, because it's moving westwards, I can take the original size of my angle and I can plus my change over the number of years that have occurred. So I say 100, and you've got to do minutes with minutes, so don't plus the minute change to the degrees. So 160 minutes plus 28 minutes gives us 188 minutes. So we've got 20 degrees and 188 minutes. Now you in essence could leave it like that, but it's incorrect to have your minutes going over 60 minutes, because we know that 60 minutes represents a degree. So if I take 60 minutes out, I know that I can actually divide that 3 times and pull 3 degrees, in fact, out of 188 minutes, and I'll be left with a remainder of 8. So then I can add that on, and I can say that it is 23 degrees and 8 minutes. That then means that the size of the pizza slice, and we always end off our answer, west of true north. So that means the size of that pizza slice, the size of the angle between true north and magnetic north, is in 2021, for this example, 23 degrees and 8 minutes west of true north. Now, if the sum had asked us to work out the change, or to work out how much it had changed by if it had started to move eastwards on average, that then means that the pizza slice is now no longer getting bigger, but actually on average getting smaller. So the difference between true north and magnetic north is getting smaller. And so instead, you would do the exact same steps, but instead of plussing your change over here, we need to minus the change. So here we're now saying 20 degrees, 28 minutes minus 160 minutes. So what you can do is you can borrow degrees and turn them into minutes to make this a bigger number. So I'm going to borrow 3 degrees here, but turn them into minutes in order to make that a bigger number. So I'm going to say 60 plus another 60 plus 28, and that will give me 208 minutes and 17 degrees there because I borrowed. And that 208 minutes now minus 160 gives me 48 minutes remaining. So we now have 17 degrees from before and 48 minutes. And that's because we minused the change. So then the size of the pizza slice of the magnetic declination angle in 2021 would be 17 degrees, 48 minutes west of true north, because it's still to the left of true north, the size of the angle, but it's just slightly smaller than when it was originally measured in 2001. So we're going to use the angle of 23 degrees and 8 minutes, assuming that in our example, the angle actually increased as the information tells us, because it moved 8 minutes every year on average westwards. So it got bigger. And so now what we can do is we can say that the pizza slice is 23 degrees and 8 minutes. That can go into our actual formula. So if we write out that formula again, we've got true bearing plus magnetic declination, okay, the current one, will equal the magnetic bearing, which is what the question is asking us to calculate. So the true bearing we haven't worked out in this particular sum, but we have worked out the magnetic declination, okay? We got it as this answer here. So let's now work out the true bearing, and then we can add the two together. Question says, from the clinic in B1 to the spot height 1731 in C2. So from the clinic in B1 to the spot height in C2. So if we highlight those points on our map, and this is the Harry Smith map in your textbook, then you've got your clinic over here in B1, obviously not the name, but the building. And you've got your spot height 17. Just got to go off this. That is your ending point. So we know we are going to measure as our starting reference from the clinic. That is our starting point. And I always tell you to highlight the place where you're going from as a reference for yourself to know that that is where your starting point is. So we know that that is then where we're going to have our north reference. And that is our true north reference because we're doing true bearing. We then connect to the spot height as accurately as you can, which you could probably do more accurately on paper. And you measure the angle from true north to the actual spot height. And you measure that with your protractor using the true bearing method. And when you measure that angle, I've done it on screen, so you might be a little bit more accurate, but I got about 148 degrees. Okay, sorry, I just want to tap on here so it allows me to draw 148 degrees from true north to the spot height. So that is then my true bearing for my formula. So I go back up to my formula and I'm going to now substitute all the information that I've got. I have 148 degree true bearing. I have a 23 degree and 8 minute pizza slice magnetic declination. I can then say 148 plus 23 degrees plus degrees will give me 171 degrees and 8 minutes. And that then becomes the magnetic bearing answer.